Okay, so to return back to our enemy and the example that we have here in main, it's all fine and good to have a few enemies. But what happens if we want to have a large number of them? It's going to be really intractable to be creating enemy E1 and E2 and E3. So what I'd like to do is comment all of this out, because we're not going to be using it, although it's good to have as a reference. And I want to talk about how to manage large numbers of elements or collections. And I have two things that I'd like to talk about in this session. The first is how to use an array. And an array is a contiguous, homogeneous collection of elements. And it's homogeneous in that it's all storing the same type of thing. And it's contiguous in that the amount of memory that it's using is all in the same spot, and so it's very easy for me to jump to any particular element in the array. Now, to declare an array, the syntax is real simple. I just start with the data type that I want the array to hold, and then I use this square bracket notation. So that is the open square and closed square brackets here. And now I have an array of integers, and then I'm going to give it a name. So let's call this values. So now values is a reference to a space in memory that's going to be holding a collection of integers. Now right now values is pointing to nothing, so just like we did when we wanted to declare a particular object of a class type, I'm going to use my new command, and I'll say values is equal to a new integer, and then I specify how big or how many of these integers I'm going to hold inside of my square brackets. Okay, so now I've got a space in memory large enough to hold 20 integers, and the reference to that space in memory is called values. Okay, so I can put individual variables inside of this values collection by using my square bracket index notation, and then I put an integer in there that says where in this array do I want to place this value. So I'm placing the value 42 into the 0th or the left-hand most element. We start counting at 0 because this is really talking about go to values and then how much further into that memory space do I want to go. So I could fill this in by saying values of 1 is equal to 9 and values of 2 is equal to 13 and so on and so on. Now values is an integer array, but values sub 0 and values sub 1 and values sub 2 are integers because it is a single element or a single entry into this array class. And just like I can store values into it, I can print things out. So I could say value at position 0 is equal to values sub 0. And if we run this now, then we should get the number 42 to go to the screen, which is exactly what we get. The value at position 42, or the value at position 0 is 42 because into position 0 I stored the number 42. So that's how you write data into an array and how you read data out of an array. Arrays are also really useful paired with for loops. So let's create a for loop. We'll go from 0 and so long as I is less than 20. And I'm going to say that values sub I is equal to 100. Or let's make it interesting, we'll say it's I times 3. So I is going to go from 0 all the way up to 19, and we're going to multiply that by 3 and store it into this values array. At position I, notice I can use the variable I as the index into the array. So now at the end of this for loop, I'm going to have all kinds of values stored into this array. And then I could create other code that would print it out. So let's just do console write values sub I, and then we'll put a space in between each, and then we'll do a console write line at the end of this loop. So let's pull it out of the loop and put it right down here. So now I'm going to loop through and fill up the values array, and then I'm going to loop through and print them out. Now this isn't really a application that you would pay a bunch of money for, but it does demonstrate how I can access and also read and write into this array. So let's run it. And we should get the multiples of 3 inside of this values array. So we're printing it out. Notice it goes from 0 to 19, and we get the exact output that we would expect. Okay, so arrays are really good, but they have a limitation in that they're fixed in size. And so what happens if I wanted to add more than 20 elements to this? That's problematic in that I would have to create a new array and copy everything over. Better would be if I had the ability to dynamically size this. And that's exactly what I'm going to show you next. So we have a new data type called list, and I pass it with the less than, greater than brackets, the type of thing that I want this list to hold. Okay, I'll call it my list, or my collection is equal to a new list of integers. Okay, and it's giving me an error here because it doesn't know what a list is. So let's right click on that and resolve it, and let's add using systems collection generic into up here, our using clause at the top of this, and now we're going to be bringing in the system.collections.generic package, and that's going to give us access to this list data type. Okay, so my list is a reference to a list of integers, and then the new command is going to go out there and create memory large enough for me to add elements into this. So I can say mylist.add, and then I simply pass it the value that I want to add into it. So let's add a couple of values. Okay, and then I can say console write line my list, and let's see what we get. Let's run it. And what goes to the screen is system.collections.generic list holding int 32s. That's not really what we wanted, so let's, instead of doing console write line on my list, which is the collection itself, let's do a for each loop. For each integer n in my list, print out, let's do console write, n plus space. And then at the end of that, let's get a new line after our for each loop. Okay, so the for each loop is going to go across an entire collection. This is the collection name, and we're going to temporarily say I need a value, pull out of this, and use that inside of my for each loop. So this is going to iterate across the entire collection and then access each individual item and display them to the screen. So let's run this. And now we should get 42, 9, and 13, exactly what we wanted. So the good thing about a list is that it's dynamic. I don't specify how large I want it to be. It just keeps growing to accommodate whatever it needs. I can also, notice, do a lot of different things. I can clear the list out and empty it. I can do a search, like a find, right? I can also remove at. So let's say we want to remove the second element. Now remember, we start counting at 0, so remove at is going to remove the second item. Let's do that after we print this out, and then let's print it again, and we should see that the number 9 is removed. So let's run. And indeed, we get 42, 9, and 13 for this first for each loop. And now that I've called remove at, it's going to remove that element 9, and we're left with 42 and 13. Brilliant, exactly what we want. Okay, the last thing I want to do is give you another example of managing a collection, and in this case I want to manage a collection of enemies. So here we could create an array of enemy, or I could create a list of enemy. So since we're going to have a number of enemies coming in and out of the screen, let's create a list of enemy called my enemies is equal to a new list of enemy. And then into this list I can add new enemies. So let's go up here and add E1 and E2. Right? Or we could, so I'm going to copy this code to create a new enemy down here, and let's create a for loop that adds a bunch of enemies. For int I equals 0, I less than, let's say we want 30 enemies, and the work that I want to do is my enemies, this collection, add, and what do I want to add? I want to add a new enemy, and I'm just going to pass it this information. So I'll call it lizardman plus I. And that's going to uniquely identify each one of these. So lizardman 0, lizardman 1, lizardman 2. They're going to have the same health, but let's say that his attack strength is going to be 10 plus 2 times I. So the first lizard is going to have an attack strength of 10 because I is 0, and then the next lizard is going to have an attack strength of 12, and then 14, and so on and so on. And I can place them at different positions. Let's say I minus 10 and negative I. Okay, so I'm going to use this variable I as properties for the constructor, and I'm just going to keep adding these enemies into my collection. And then let's go ahead and use our for each loop again. For each enemy, E in my enemies, console write line E. So then we'll iterate across our entire collection and print out all of our enemies, and what we should get is about 30 enemies on the screen. So let's run this, and here we are. Here are all of our enemies. Lizardman 0, 1, 2, 3, 4, 5, 6, all the way up until 29, and each one of them has the same health, but each of them does different damage, and notice they're all at each different positions in our world. Okay, so from all of this, you should get the idea that I can create arrays, which are static and fixed in size, or I can create lists, which grow dynamically. But either way, they can hold primitive data types like integers, or they can hold more complex types like the class enemy that we just declared. And in the next segment, we'll talk about how to inject randomness so that our enemies can be in different positions.